Let's go to the final example, example number 7. Let's read out the question. An open box with square base has a total surface area of 300 cm squared. So this is given, the shape is an open box, alright? It's an open box, you don't have any cover. And then you have a square base. Since you have a square base, the length and the width should be the same. So here I use the variable x. And for the height here, let's use another variable. Let's use y. So this is the constraint given, which is total surface area is 300 cm squared. So just keep this first. So this is your objective. Find the greatest possible volume. So the greatest here means maximum. So let's write our objective. You want the greatest possible volume. And number 2, let's define our variable. So x here is the width and length of the base of the box. And y here is the height of the box. So be careful, length cannot be a negative value. Number 3, let's draw our formula. The objective is you want to find the volume, right? So volume is the length times width times height. So x times y. Let's simplify. V is equal to x squared y. So let's keep this. And we know that we have 2 variables right now. Later on, we need to make sure we only have 1 variable. So who will help us in this case? The constraint. All right, so you're given the total surface area is 300 cm squared. So now let's build up our total surface area. So you only have 1 base, you don't have any cover. So for this one, the area is just length times width. So x times x. That's right here. And then for the 4 walls here, this is just the length times the width. So x times y. And then you have 4 of them. So 4xy. Let's just add them up. Let's simplify. This is x squared plus 4xy. And let's substitute a total surface area as what's given in the question. It is 300. So now 300 is equal to x squared plus 4xy. So in order to substitute in this, we need to keep x and we need to substitute out y. Therefore, let's rearrange this constraint here to find y. So this is it. Just keep this one, bring it to the other side, minus, and let's divide with 4x. Therefore, this is your y. This is the second equation. So let's substitute 2 in equation 1. So this is it. V is equal to x squared y. So let's substitute this y here and let us simplify. So this is it. This is your V now in 1 variable. So now you're ready to differentiate so that you can get our critical point. So let's find dv over dx right now. So just use power rule, bring down the power reduced by 1. And let's simplify. So this is your dv over dx, which is 75 minus 3 over 4 x squared. In order to get the critical point, let us equate the first derivative to 0. So 75 minus 3 over 4 x squared, equate it to 0. Bring 75 here and eliminate the minus sign. And then cross multiply 4, divide by 3. Square is 100. Therefore, x is plus minus. So be careful. Do not take the negative sign. Length must be always positive. We have mentioned this before. Therefore, we can conclude that our x is equal to 10 cm. So just now, we have the value of y is equal to 300 minus x squared over 4x. So now let's substitute the value of x here so that we can get the value of y. So let's fill in 300 minus 10 squared over 4 times 10. So this will give you y equal to 5. So this is very important because later on we will substitute all of this later. So after we got the value of x here, we need to prove that this point here is a maximum point. So what should we do? We need to do second derivative and then we need to check whether it is positive or negative. So from dv over dx here, let us find the second derivative. So just use power rule, bring down the power reduced by 1. So this is minus 6 over 4x. Let us simplify. This is just minus 3 over 2x. So since you still have the value of x, we need to substitute the value of x here. Therefore, when x is equal to 10, second derivative is equal to negative 3 over 2 times 10, which will give you negative 15. So let's conclude here. 15 is negative, so it should be concave down. Therefore, it is proven that you have a maximum value. So now let's conclude our answer. Since the second derivative is less than 0, thus the greatest possible volume occurs when your x is equal to 10 cm. Therefore, we can find the maximum volume, which is v equal to x squared y. So let's fill in. Your x is 10, your y is 5. So 10 squared times 5, this is just 500 cm cubed. Therefore, this is our final answer. So that's the end of this chapter. Assalamualaikum warahmatullahi wabarakatuh.